So I want to give a brief intro to the ground rules for the fellows' presentation. So each fellow has a very strict limit of 7 minutes in which they will presenting. So this is a true pitch demo for you all. And then we will ask the audience to give them 1 or 2 questions after their presentation. So don't go easy on them. Please give them some tough questions, and please try to help us out by thinking some of those. And so I'm going to introduce our first fellow. This is Steve Weiss, and he is going to go first as soon as he is set up. He is a startup founder. He's a fantastic engineer. He worked at Facebook for a long time, and now he's going to talk to you about classified threat sensors for national security. So over to you, Steve. You get both. No, you need both, actually.
Yep. Good evening, everyone, and thank you very much, Betsy and Nicole. I'm glad you all made it here tonight. My name is Steve Weiss, and tonight I'm going to be talking about detecting nation-state cyber attacks with classified threat sensors. This was joint work with myself and Dr. Aloni Cohen and Dr. Amina Asim. And high level, the problem we were looking at is that private companies are under attack by foreign nation states. So you think about Google with China, Sony with North Korea. These are just private industry companies that have to actually defend themselves against the entire nation, against China, against other countries. So we looked at what we could do to actually help tip the balance to private companies' favor. And through the process, we talked to a lot of different CISO and technical people and government and private industry. And one kind of common theme that came up was threat sharing. So a lot of the feedback we got was that companies would like to get better access to intelligence from government. And one challenge is that some of the best threat intelligence is classified. And companies can't access that because intelligence community can't really give a company like Google classified intelligence without leaking its methods and means of actually collecting it. So this is the problem that we ran against and we're thinking about solving. The challenge here is, imagine you had a private company network and they have security logs, and as a cyber attack happens, it leaves things called indicators of compromise. This might be like IP addresses or URLs or file hashes, and these would appear in their logs. Now, their threat detection can't detect it unless they know what they're looking for. And while there's private companies that have threat intelligence feeds, there may be things that are known on the government and intelligence community side that private companies do not yet. So the question is, can private industry apply classified intelligence without leaking it? And to achieve this, we have something we call a classified threat sensor. And essentially, it's software that can be run by a private company that can take encrypted intelligence and use it to search over your own security logs. And we're calling this CANARY, which is a backronym for Classified Analysis of Network Attacks in a Restricted Execution Environment. And I have to thank Alani Cohen for coming up with that, because it's great. The technology we're making use of is something called a secure enclave. And you could think of this as a small, safe space to run your software inside a processor, inside a CPU itself. And this lets you run your own software on somebody else's computer with the guarantee that it'll run the correct software, and that computer's operating system can't actually see inside the enclave. So it's a very nice building block. And one example is Intel's Secure Software Guard Extensions technology, or SGX. So that's going to be our building block for this. And how it's going to work is that we have our classified environment and unclassified environment with the respective data. And you'll have your own private computing resources that are enabled with Secure Enclave. So you're using Intel CPUs. Part of this will be based on a open source project. And this will have 2 components. One is a verification service, and the other is the actual canary, which is the bird icon in the enclave itself. And that's a small program. So once that's started, the way that you'll actually search for threat data is that the verification service will first make sure that you're running the right software. And that's very important because this classified intelligence agency can't give you the encrypted data unless they know it's running the right software. Once it's verified, they can take their intelligence and encrypt it and then send that straight into the enclave, which is inside a CPU on a private company's computer. And this data is not visible on the network. It's not visible to that computer or that organization. It just goes straight into this little safe space. And once it's in there, you can start searching over that local private data, those local security logs. and then return either a hit or a miss. And this is also important because we don't want this to be PRISM, where the intelligence agency is sucking data out of the private company. It just tells whether something is seen or not seen. Now, what you do with that is, if the canary dies in the coal mine and it sends that something happened back to the intelligence agency, they'll just escalate to a person. So they don't know what it is, they don't know what was seen, but some person's gonna have to get involved and be notified that this company had something seen, you need to contact them, and then from there, you would escalate through some legal or law enforcement process, kind of the regular channels you would today if you found out that there was something going on. So the intelligence agency would learn as these are deployed whether there's trends across many companies, and then the company would be able to get notified if they're under attack that they wouldn't otherwise know of. So the high level is that Canary lets you apply encrypted intelligence inside a secure enclave, and this can be used in multiple scenarios, so government, industry, and for that we've kind of outlined a 5-phase plan. First would be an open source project, and then there'd be various different trial deployments. So an industry one, government, and then finally government to industry sharing for unclassified, and then finally classified information. And the nice part about this is no matter how far you got into these phases, each one has some value. So even if it was just an open source project or that you just had an industry trial, that's something companies could use to share data with each other. So it's a nice building block that you can use in lots of different contexts. So to achieve that first step, we're proposing that $150,000 in funding be provided for a couple student developers and researchers, along with a professor or principal investigator, to deliver a proof of concept that kind of has the whole end-to-end system of the verification server, the enclave, and then also ingressing the threat data in the standard format. And this would be something you could build out in 6 months over a semester with a couple students. So I'd like to wrap it up there and thank some of our supporters, so Craig Newmark Foundation, the Hewlett Foundation, Almadyar Networks, and Mozilla. And if you'd like some more information, on the bottom there, that's the domain, canary.info. That has a video, some slides, and some paper write-ups about this. And I will wrap it up there and take questions.
We'll hold your applause until the questions are over, and save your questions, please.
Sorry, I don't know how, is it okay if it's a very specific and tactical question? Great. So the 150K, is there a reason that is it already funded through those foundations that you had on the last page? And if it's not, is there a reason to do it as a grant instead of equity? Because there's just a lot more equity capital, or there's a lot of equity capital searching for stuff that looks compelling like this. So it's it would be easier to, yeah.
I mean, you could use this as a technology first startup and try to sell some threat intelligence software. I like the idea of doing it under a student grant because the output would be open sourced, and then you could have it adopted for different scenarios and also used for other applications. So this idea of doing kind of searching over private data, it's not just for threat intelligence, but could be used in lots of contexts. But yeah, there's nothing precluding it from being a private company going out and building this on their own.
Hi, could you please go back to the slide where you talk about the classified service?
This one or?
The one before it, I think. Yeah. So there's a verification service that's in the classified box.
Yes.
Do you expect the verification service, and I imagine the verification service is deployed in the secure enclave, do you imagine that to be like a continuous link? So that's my first question. My second question is, don't you think there's something some kind of philosophical, makes you feel bad idea that there's a container in your own computer that is basically a black box? You don't know what's in there. That could be could be a security threat, could be a risk. Bad actors could have access to it. There could be a virus running, could be selling your data. That's my question.
Yeah, so the verification service is just at startup. So that would be used to identify the enclave and then basically get key material out of it. The second question is basically already exists in your computer. So there's already microcode and then environments that are running that you don't have any visibility into. And I am blanking on the name of it. I want to say SMC, but I'm wrong. But this exists already. So there's opaque code running on an Intel processor now that you can't see. And this one is actually auditable because it's an open source project. And so if you run this, you see the source code, and you could measure that that's actually running, because that's actually a very important part of it, because you as a company need to make sure that this thing is not sending back, search records over your data. You have to actually audit it and believe that it's just sending 1 bit. I think Eric had a question?
Right. Eric Rose, former paranoid CISO type person who was dealing with this kind of system that wasn't classified. It was just a commercial system, but I still didn't trust them. And so the only way I would allow that in my network was to not have step 5. I didn't want any network traffic going back. I could accept that if I was able to see what was inside. It's okay if it's encrypted on the network, but I have to be able to see the traffic that's inside 5 so that I can verify search traffic's not being released. Is that still feasible within your model?
So this brings up a good point. This is almost 2 untrusted parties. So we don't want the classified agency to mine data from the company. We also don't want the company to mine data from this enclave. And so the reason that this has to be encrypted and sent back to an intelligence agency is that this company could send adversarial stuff to this enclave, and if they see the results, they can use it as an oracle. There might be some settings where you could do this. We'd have things that were rate limited or other ways of having this detected, but on this design would actually limit that. But there could be models where you relax that and you have some trust that the private company is going to be honest but not malicious and not try to query this thing.
Thank you so much, Steve.
Thank you very much.